All right, here we are again. Today is nebulas and stars. We're going to go into more detail on stars later, but how are stars formed? Nebulas. How are nebulas formed? Exploding stars. So we're going to have this kind of a cyclical chicken or the egg debate kind of going on here. Which came first, the nebula or the star? The true answer is the Big Bang. The Big Bang created this gigantic cloud of gas and dust. Well, it was a soccer ball size cloud of gas and dust, and then it got bigger. But I've gone ahead of myself. Well, let me just say that, first of all, I'm going to use a magic clicking device to change the slides. That's a stapler, by the way. I'm going to change the slide. The reason I'm doing this is every time I see the stapler, I know I need to change the slide on the background. And so what I'm going to do is put the door to the classroom up there because, hey, there's the classroom door. Hey, and now I have to say my standard traditional thing. I need to do this because you guys are going to hate me if I don't say, hi, how are you today? How's it going? It's good to see you. I didn't greet you at the door today, did I? I forgot to greet you at the door. So now, nebulas and stars and star formation. There's going to be a couple of videos on this subject. It's going to take a little bit of time, but it's really fascinating. The most beautiful objects in the sky anywhere are nebulas. And so we're going to talk about nebulas. So nebulas, about 90% hydrogen, 10% other, all the elements. A lot of helium. So 90% hydrogen, gas and dust. Remember gas and dust? It's our favorite word for the semester. We're going to use gas and dust a lot. And so hopefully there's a picture of a nebula up here. I forgot to change the door picture. Now I'm going to change it to a nebula. And probably the Eagle Nebula because that's the one I want to talk about the most. And so nebulas, all these different colors, all these different shapes. Some are chaotic, some are symmetrical, some are fancy, some are plain, some are just brown. Very exciting. Yeah, you look up and you go, oh, that's brown. Yeah, sometimes to see all the colors you need an X-ray telescope or an infrared telescope or visible light telescope or all three, which I'll explain later. So nebulae, giant clouds of gas and dust. Some of them are less than a light year across, some of them are 7 light years across. They're very, very large structures. And they are mostly hydrogen. That's on the test. What's the most abundant gas in the universe? Hydrogen. So now, 3 types of nebular material and 2 categories of nebulas. I don't know how to say it better than that. There are 2 ways to make nebulas and 3 results. How's that? Is that better? So the 3 results are emission nebula, reflection nebula, and dark nebula. Dark nebulas are very cleverly named for their appearance. They're dark. You can't see the stars behind them. They're just cloudy. It's a gray and brown mass of no light coming from it. You look at it through a telescope and you go, that's a cloud. Look at that, some dust, some gas. Wow, pretty cool. It's a dark nebula. They're just dark. And the little ones are called Bok globules. I am not going to ask you what a Bok globule is on the test. That's just, I'm not really worried about it. They're less than a light year across, but they're dark nebulas. Then we have emission nebulas. They are red, almost always. Bright red, pink, sometimes orangish, and they might be mixed in with another type of nebula, but the red ones are emission nebulas. They are collecting ultraviolet light from the stars around them, converting it into red light and emitting it as that wavelength. And so it's some basic quantum mechanics. Light gets absorbed in the ultraviolet spectrum by the electrons. The electrons get all excited, woo, and then they calm down. And when an electron calms down, it re-emits those photons, but never the same frequency as it was absorbed. And so ultraviolet light gets converted into red light through basic quantum mechanics. And that's an emission nebula. They're red, they're emitting red light. They're making red light. They're not reflecting red light. The next one, reflection nebulas, they're blue. I'm going to ask you which color are most of the emission nebulas. I'm going to ask you what color are most of the reflection nebulas. They're blue, because the blue light scatters really well. Light from around them is passing through the cloud. Stars from behind them, the light's coming through the cloud. The cloud scatters the blue light. The blue light is much easier to see than the other colors. The other colors are kind of absorbed in, or not, just depends. And so you get these blue reflection nebulas that are pretty cool looking. Then there's the 2 categories of nebulas, which is how they're made. Some are made by novas, which is a small star exploding. Some are made by supernovas, which is a large star exploding. Nova remnants are called planetary nebulas because they were mistaken for planets by early astronomers. A planetary nebula is small, less than a light year across. They can be very, very colorful or brown, like a Bach globule. And so if they're colorful, you will see layers and rings, and the layers and rings will go out from the central point. I should put up these on the screen. I should be doing this. Hey, look, that's a planetary nebula. I'm going to try and find a planetary nebula. If you look at it, there's a small speck in the middle. Somewhere over here, there's a small speck in the middle of whatever nebula I just put up. It's a white dwarf. It's a star that went nova, not supernova. A planetary nebula is a medium to small star. Those are always called dwarf stars. There's no such thing as a medium star. They're called main sequence dwarf stars. And they explode as a nova. The nova makes a planetary nebula. Layers, like onions, like ogres. There are layers of color. Then there's the other category, supernova remnants. Shockingly, it is named for the explosion that creates them. The supernovas make the supernova remnants. So planetary nebula is going to have layers, and it's going to be concentric maybe, or it might be symmetrical. It just depends. The hourglass ones are very hourglass shaped, it's very symmetrical across a certain line. Well, supernova remnants, absolutely chaotic. No order whatsoever as far as the physics is concerned. It is just chaos, which is just math that we're not sophisticated enough to understand because it's too complicated. But anyway, supernova remnant nebulas, that should be a supernova remnant nebula. Hopefully the Eagle Nebula, because that's the one I want to talk about. Supernova remnant nebulas are very large, very chaotic. They will have emission nebulas and reflection nebulas and dark nebulas in one supernova remnant. If you look at the Eagle Nebula, there is a dark nebula in it called the Pillars of Creation, and they are the most abundant brand new baby stars being born every day. It's called a stellar nursery. Stellar nursery is on the test. Where stars get made, stellar nurseries. It's a nebula, usually a supernova remnant nebula, usually a dark supernova remnant nebula, but you can get stars being made in reflection nebulas and emission nebulas. I'm not saying you can't, I'm just saying the dark nebulas have more matter to make stars with. And so you've got three types, emission, reflection, and dark. You've got two categories, planetary from novas and supernova remnants from supernovas, all on the test. And I want to talk about the pillars of creation right now. So where are stars being born? Stellar nurseries. And how are stars being born? Well, gravity, a little bit of love maybe, and mostly gravity. And it coalesces into this sphere called a protostar. Protostars are brown, and they are cloudy, and they look like clouds of gas. And so in the pillars of creation, if I put the right picture up, there's a pillar, big, medium, and small. Well, big, medium, and small. We'll see if we can get that right when I put the photo up. There are little offshoots from each one. They look like little lines with a little nodule at the end. That nodule contains 5, 7, 15 protostars. The protostars are not fusing hydrogen yet. They have not ignited. In order for them to ignite, they need a pressure wave. So if a star over here forms and this little nodule over here has protostars in it, the pressure wave from that star formation nearby will come along eventually and ignite the protostars. And so maybe one will ignite, maybe all 12 will ignite. It just depends on the circumstances. You gotta have enough mass, you gotta have enough gravity, you gotta have enough compression from the pressure wave. And so you get these ignitions where fusion begins in the stars, in these protostars inside inside the stellar nurseries. So the next video I'm going to talk about how the star grows and changes with time. But I want you to look at these nebulas real quick and tell me what kind of nebulas do you think they are. The first one I want to put up, let me remember to, magic clicker. The first one I want to put up is called the Red Spider. It's red. It's all red, lots of red, some orange. Guess what? It's an emission nebula because it's making red light from the ultraviolet light around it. If we put that one's in Sagittarius. If we put the Lagoon up from Sagittarius, very colorful, kind of, chaos. Definitely a supernova remnant. The Red Spider was also chaotic supernova remnant. You might argue that the spider had a little symmetry. It wasn't good enough to be a planetary nebula. The Owl Nebula in Ursa Major, very symmetrical concentric rings. Definitely a planetary nebula, not chaotic. Then there's the Hourglass Nebula. A lot of Hourglass nebulas exist, but this was the first one named Hourglass. And when we first saw it, it was red and hourglass shaped. Then Hubble took a look. And when we saw the hourglass through the Hubble, that bright, bright green eyeball shape right in the middle showed up, and everybody was amazed. That is so weird looking. It's an hourglass nebula, planetary nebula looking right at us. If you look closely, that eyeball will have a little white speck in the middle of it. That's a white dwarf because it's a planetary nebula. It has symmetry, an hourglass shape. It's symmetrical. And so you've got this very symmetrical with this really bizarre looking eyeball staring straight at you. It's really cool looking. The Eskimo in Gemini, the Eskimo Nebula has the big furry fluffy thingy around what might be a face. It could be a face. There's some symmetry going on. There's some rings. There's some layering. There's a bunch of different colors. Definitely a planetary nebula. And then one of the coolest looking ones, if I remember to put it up there, the Butterfly Nebula. Very cool looking. Definitely, I want y'all to figure out, is it reflection? Is it refraction? It's definitely not a dark nebula. The Butterfly is not a dark nebula. And see if you can think about, what is that doing? Is it red? Is it blue? What's going on? I think that's all the nebulas I wanted to show you. Oh, no, I like the Witch Head Nebula. The Witch Head Nebula is really cool. Check that out. That's the Witch Head Nebula. And all the videos I want to show you that I can't show you because they are on Discovery Ed and I can't send you that password. They take the Witch Head Nebula, they put it in the, watch how the universe works. Just watch as many episodes of that as you can. It's an awesome show. They take that nebula, the Witch Head, and put it in the background of everything and make it make it different colors just to make it look like they're changing the background, but they're not. It's the same background behind all their animations. The Crab Nebula in Taurus. The Crab Nebula is very cool looking, and you can't see any of those colors through the Hubble. The Hubble takes pictures of that one and it sees gray and brown. That's the visible light part of that nebula. The Chandra X-ray telescope takes pictures of the X-ray spectrum and it provides the greens and the blues for this picture, and the yellows and oranges comes from the Spitzer infrared telescope. If you combine all three telescopes together, you get the image of the Crab Nebula right here. And if you look, the Crab Nebula has a little white speck in the middle of it somewhere that pulses. It's a pulsar. It's actually a neutron star that rotates so fast that these pulses of radio waves come out of one of its poles, and that pole rotates past the Earth every once in a while, so we see the pulse. That's definitely a supernova remnant. It has a neutron star or pulsar type neutron star in the middle of it, making us see these pulses of radiation come out. And so those are some really cool nebulas that you can look at. I am going to ask on the test, what kind of light does the Hubble take pictures of? Visible. What kind of light does the Chandra telescope take pictures of? X-ray. What kind of light does the Spitzer orbital observatory take pictures of? Infrared. And so those are all going to be pieces of information you need to know. Hopefully that wasn't too boring.